Tony Betty Sola. Ibuloke da Tony Betoto.
Bengi. Bengi Congo.
Lamin.
Na.
Lamin de jibe norin te nyame Lamin.
Kabana wulo kono.
Wulo kono nyinta mo Lamin.
Fabilenki.
Muna ngata afongole.
Haina.
Ngata. Ngoto le. Fabrama.
Bengi. Baba nyola.
No ngoto le.
Tumara kan kuma ni ten.
Fabrama.
Tumara mu.
Ndele bare muso.
Lunda mana.
Famo kata.
Jamani bere.
Alindo ko.
Jamani.
Bari ngoto man kontande.
Bari jamani fana na mudu ma kontan.
Ngoto minaka ngala min de fon filitala. Lamin jibe nori nyaala.
Lamin ida siran sama ne benki. Yala so tol sayni no ko mo lakko momo.
Ngoto.
Nam.
Itedinte yalo ne Lamin hakkilo diata bake karambu ngoto. Anu santeng ministry ko di ngole si suwo ko amake ko do holiday la
si bitun
bagona de
ala ni ku kede namo balo
ala ni na ko ina karta bulo be damna ala ni je
ngoto
nam
ngoto mon kontan fere
jamani mu ne keda
ite ka Lamin ki wulo ko no nyintay mon ko do fete malo Lamin nyanta sila la be la moy kala karamo
jamani karamo be soron kono ko
karamo wol ma soron ni ko karamo wol soron da amake ko holiday lem ngoto di ni nyanta ngola moy yamen kamen fue man kontan anda mande
alla nyin kombo courant adanda lo kombo ndo la jankara mol soron da doron kamen courant ma rado lo kombo e don dol fanena kara mol soron jay kara mol soron Lamin ada lo nyino la man tara fe na suxon ala mu nekela
am Lamin ite foyde malon ko lesinol be ke kar radio to
nga fine
e ko nyina di mod Lamin ya mu na fonye
kabin mina kan tambita nteri maning Fatu tambite la suxol ala dinngol bebe siri be la moy ka
faru danso am fana tambira jele ni subala da ngaje dinni ngol be je talanta nen kili waro e be serin jele
sa Lamin farante ku kili woke no la ba Lamin bitaka wulo ko no nyun taymo Lamin
aman dara fenela
ite dine ko ni man si yakari la suno la moy radio to balon na
muneka ke afanye ba nyara ni alon
telentel jikot
afanye ba munebe ke
ite balon tel be jikritel ni man karambe ku kele yaje nata karana mbasa malaya ay tarije
par ñarande kombo courant ho findira kombo ide na raje den sonka bay ko Lamin manya tala wulo ko aru karam wolbe so afanye membe
ko to wole nati bawo ngalle ni Lamin kuntala courant o ka fa me kombo courant asototal wala kinay ko e si suwo kono bari ni ko e si suwo kono be karangol di ke la radio lin telel to hani tele masoto to nyaay man tele soto da bongo bar radio be bulen koto batiri sanga ay si ay alamo
sa do kala
nyaadi ko ta ro bulaji
abe ko kala nyaadi
kamun ke nyaadi
radio abe wala moy la be mona falaje
ibe la karandirol kala jele
ti talle be radio ko men ga karandi
ila subjector baby jele baby jele
wala nanga coco moy fa dan so wolya ngombe tambi kan ngadi ningol jebe ikadum bungo ko kada mal mona
asototal de
Lamin mala be kara wala de
bari
lafta alal ideal on ko inde every year second wala fourth
mona ni ko ma ko nde ko folle sini lamba nde le sini lo ne ba
say mba foke en koto wole fango yen wulindi yalo famo keta bat yim fadam bulata ko ko me yen nati jambi Lamin nyanta karana ntel beji ko be nyine ka ya bulay kara wulo kono ta kilar ya bambalo yo be bulaje ko to dindi ngoy si ayala le sino la moy radio
wala ka munda kara mo man soro Lamin nyanta kara si suuna radio
la sila le ayala le sino
dal ko korna ko smolon
kilar ya
mo be ngala ko momo say mi do ni faro kera
mengi bruce
ndelo ko do la da ba rosa no radio ba no bari woro radio ni abe jele ba ngamra do man me guljan dala nyara nyar wo ko fendi mo la Lamin tayra ba rosa
bara te ku folo ajibe nori nya labi tamete ku
teku
bari ko do famo ke
imagine nani nyambol si je ole ke je kisigi man si je ol no le kafun ka nyoma bari nyambu kinol ni manya na kafinde ni nambe ko so la jang
ngalle limbeta de be nyambo do dilanna
nyara ni ko rin fennat nyara nata
kada
ngata bungono tambi bungono nyara ngando ko fele ko ke baru nganda ni pelo la dija
iyo awa betar la
bungono bismillah bisu diara
Pendulala. Ye fungo tanka sina dolu tanka. Koro ta koro
Hello viewers and listeners, welcome again to another mathematics lesson of the upper basic sector. Solving equations by elimination. As you all know, we did solving equations by substitution already. So today we'll be looking at the eliminational aspect of it. The additive inverses. This is a prerequisite to elimination. Of course, we should know the additive inverse of numbers to make them 0 before we get into the lesson proper. So let's talk about what's happening with these numbers. Negative 2 plus 2. Our first number here is negative 2. And the additive inverse, the inverse of negative 2 obviously is positive 2. So therefore, positive 2 is the additive inverse of negative 2. And it also nullifies negative 2. Negative 2 plus 2 equals 0. As we are eliminating, all we do is, we want this off. We can only do that to negative 2 by adding 2 onto it. So therefore, this becomes 0. This shows that we have eliminated negative 2. Okay, we have undo negative 2. So we have 0 now. We have 3 plus negative 3. 3 plus negative 3. This would be 3 plus negative 3. For the fact that we have a negative and a positive number in the middle here, we settle down with a negative number, which will be 0. 3 minus 3 equals 0. This is a positive 3. By adding a negative onto it, it makes it 0. Again, we have negative 5x plus 5x. Negative 5x plus 5x. Negative 5x, its additive inverse is plus 5x. This also results to a 0. All this is showing us how we can eliminate our first term or first number that has been given. Again, we have 9x plus negative 9x. 9x plus negative 9x. This is very similar to what we've got here. We have a positive number, adding a negative number onto it makes it a 0. Okay? So this all is showing how we can eliminate a term, the first term that is given, by doing its additive inverse. Choosing a variable. How do we decide which variable to eliminate? This is a question that we must ask ourselves when we are to solve equations by elimination. Here you have two variables. Now, what variable are we going to eliminate? And why should we eliminate this variable? It says first, look to see if one variable has the same or opposite coefficients. Check whether the coefficients are the same. If the coefficients are the same, there is something that you do to eliminate it. And if they are opposite, you need to do something also to eliminate it. So if the coefficients are the same, you subtract. If you have 3x, positive 3x, and the second issue also gives 3x. They are all positive. Their coefficients are the same, positive 3x. All you need to do to eliminate is to subtract. But if their coefficients are also opposite, like negative 3x and positive 3x, or whatever, either positive or plus 3x, You can see the coefficients are opposite, 3x and negative 3x. If they are opposite, all we do is we add to eliminate. This will further be elaborated in our next slide. Now, whether we'll add or subtract to do the elimination. If the variables have the same coefficient, as I explained in the previous slide, subtract the two equations to eliminate the variable. I read again. If the variables have the same coefficient, if their coefficients are the same, all we need to do is what? To subtract in order to eliminate. Okay? As it is shown here, 3x, 3x, they are all positive numbers. Okay? If you want to eliminate that variable x here, we must subtract. As we did here, 3x minus 3x, which is what? 0x. Okay? Now, if the variables have opposite coefficients, therefore, we should add, as we discussed in our previous slide. Now, as we can see, the opposite coefficients are here. 3x, which is positive, and negative 3x. If you want to eliminate this variable here, all we need to do is to add. That is 3x plus negative 3x will give us a 0. Now here is an example that we'll go over. Solve the system of equations by elimination. We have two equations here. We have equation 1 and we have equation 2. Equation 1 is 5x plus y equals to 44. And equation 2 is negative 4x minus y equals to negative 34. That is our second equation. Now, the first step that we will be looking at is choose which variable to eliminate. Which variable are we going to eliminate? In choosing the variable that we are going to eliminate here, we know that the y's have the same, they have opposite coefficients. This y here have a coefficient of 1. It is invisible, but it has a coefficient of 1. And this one also has a coefficient of 1. And we can see that their coefficients are opposite. Okay? And in our previous slide, we said that when the coefficients are opposite, we need to add to eliminate. So therefore, if we want to eliminate here, all we do is we add because we have opposite coefficients. In the first equation, y there is a positive 1. And in the second, the coefficient of the y there is negative 1. So these two equations, their y's have an opposite coefficient. So in order to eliminate that, we should add. Okay? The y in both equations have opposite coefficients, so they will be the easiest to eliminate. We always settle for the easier one. Okay? And the second step is add the two variables. Because they have opposite coefficients, so therefore we should add. We have 5x plus y equals to 44. Negative 4x minus y equals to negative 34. So when we add, the addition eliminates the y's. So we have 5x minus 4x, which is x, plus 0y. Okay, it is no significance, so we need not even to write it, equals to 10. So therefore, our value of our x here is 10. The x value there is 10. Okay? We further go on to substitute the value of x in our equations. We found the x, and now we'll go and find the y. So in doing so, the value of x now is 10. We substitute the value of x as 10 in our first equation. That is 5 times 10 plus y equals to 44. 5 times 10 obviously is 50 plus y equals to 44. So all we do here is we undo the 50 here by subtracting 50 from both sides. That step is not shown. So 50 minus 50 is 0. So we have y equals to 44 minus 50 is negative 6. The value of our x is 10 and y is negative 6. So now to prove whether our equation, whether our solutions that we have, the values of y and x is right, all we need to do is we substitute the value of x as a 10 in our equations and y as negative 6. This will enable us to see whether both sides of the equations are equal. Obviously, they should be equal, that our equations are, our solutions are right, the roots of our equations are right. And if they are not equal, it shows that we are not doing the right thing. Okay? So we substituted x for 10. We have 5 times 10 here plus y for negative 6. So 5 times 10 is 50. Minus 6 equals to 44. 50 minus 6 is 44, and then we have 44 in the other side of the equation. This signifies that our root of the equation, or the value of x and y, is correct. Again, we have negative 4x minus y equals to 44. So all we need to do here, substitute the values of y and x in the equation. We have negative 4 times 10 minus negative 6 equals to negative 34. So negative 4 times 10 is negative 40, plus 6 equals to negative 34. Negative 40 plus 6 equals to negative 34, which is also equals to negative 34 on the right-hand side. So therefore, this our equation also is been proven right, that negative 34 equals to negative 34. Here is another example where we have 3x plus y equals to 15 and negative 3x minus 3y equals to 21. Choose which variable to eliminate. We can choose which variable to eliminate here by looking at the system of equation very, very well. Knowing that the x's have opposite coefficients, in equation 1, our x is, in equation 1, our 3x is positive, and in equation 2, we have negative 3x. And we can conclude 3x and negative 3x have opposite coefficients, so therefore we can eliminate by adding. Okay? So choose which equation. We have chosen that the x is fine, as it is here. The x in both equations have opposite coefficients, so therefore we are going to eliminate the x. And this has been done here properly. 3x plus y equals to 15. Negative 3x minus y equals to 21. We have to add to eliminate our x variable, the variable x. So in doing so, negative 3x cancels negative 3x. Okay, so y plus negative 3y is negative 2y, which is also equals to 15 minus 21 is negative 6. So we undo, we want to isolate our variable, therefore we have to divide both sides by negative 2. Negative 2 cancels negative 2. So we have y equals to negative 2, negative cancels negative, 2 goes into 6 3 times. Okay. So our value of y here is 3. Let us move on to substitute the value of y in our second equation. We have y as 3. The equation is 3x plus y equals to 15. So we will substitute y for 3, which is why we have 3x plus 3 equals to 15. 3x equals to 12. How do we have the 12? By undoing the 3 here. How do we undo it? By subtracting 3 from both sides. 3 will cancel 3 here. And we have 3x equals to 15 minus 3, which is 12. We divide both sides by 3. 3 cancels 3. 3 goes into 12 4 times. So our value of x here is 4. Our value of x here is 4. We can still check here by substituting the values of x and y. Okay, the value of x is 4 and y is 3. We can easily substitute them in our equations here to prove our answer here. 3x plus 15, 3 times 4, which is x plus 3 equals to 15. 3 times 4, 12. 12 plus 3 equals 15. So we can conclude that both sides of our equation is 15. 15, 15 here. So this proves our equation right. Again, in the second equation where we have negative 3x minus 3y equals to negative 21, the same, we substitute the values of x as 4 and the value of y as 3. Negative 3 times 4 is negative 12, and negative 3 times 3 is negative 9. Therefore, we can also conclude that both sides of our equation here are the same, because negative 12 minus 9 is negative 21, and we realize that the root of our equation, the right-hand side of the equation also is negative 21. So this did a perfect job here because both sides of our equations are the same. So it is correct. Now, solve the system of equation. We have x plus y equals to 6 and x minus y equals to 4 as our second equation. Now we realize in these two equations that the x's have the same coefficient, but the y's in the equations have opposite coefficients. So it is easier to eliminate when they have opposite coefficients, like in the y, the value of the y coefficient in equation 1 is positive and is negative in equation 2. So hence they have opposite coefficients. It is easier to eliminate systems that have opposite coefficients. Okay? So therefore, because they have opposite coefficients, so we need to add. X plus x is 2x. Y plus negative y will cancel. That's the additive inverse of y. And 6 plus 4 is 10. Okay? So we want to isolate our variable here. How do we isolate it? By dividing both sides by 2. 2 cancels 2. 2 goes into 10 5 times. So x is equal to 5. X equals to 5. So this is the value of x. We substitute the value of x in one of the equations here, whether equation 1 or 2. I would advise you to go for a simpler equation. In this case, they both look simple. Okay? So the ball is in your court. Whether you use equation 1, whatever you use, what is important here, you'll still get the same answer. The values of x and y will always be the same, whether you use the first equation or the second equation. Okay? So now, the first equation is x plus y equals to 6. The value of our y here is 5. So we have 5 plus y equals 6. What do we do here? We subtract 5 from both sides to undo the 5. So we have y equals to 6 minus 5 is 1. Okay. So our value of x here is 1. Our value of x is 5 and the y is 1. Solve the system by elimination. We are again solving another system of equation by elimination now. We have 2x plus 5 equals to negative 5 and 2x minus y equals to negative 3. Okay? As we can see, both equation x 1 and 2, the x's have the same coefficient, that is 2 in both equation 1 and 2, but the y's have an opposite coefficient. So it is advisable to eliminate those with opposite coefficients first. Now we have 2x plus y equals to negative 3. The y's have opposite coefficients, so therefore we add to eliminate. We have 2x plus 2x is 4x. Y plus negative y will cancel, that's the additive inverse, cancels it to 0. We have negative 5 minus 3 is negative 8. We divide both sides by 4 to isolate our variable. 4 cancels 4. 4 goes into negative 8, negative 2 times. So x is equal to negative 2. The value of our x is negative 2. You can further go on to solve the value of y by substituting the x values in the equations that we have. Equation 1, we have 2x plus y equals to negative 5. So all we need to do here is substitute the values of x. We have 2. The value of x here is negative 2 plus y equals to negative 5. Negative 2 times negative 2 is negative 4 plus y equals to negative 5. We can further move on. We want to isolate our variable y here. So we can add 4 onto both sides to isolate our variable. Negative 4 plus 4 is 0. So we have y equals to negative 5 plus 1 is negative 1. So in the equation, we can see our value of x is negative 2 and y is negative 1. Solve using elimination. We shall solve this using the eliminational method here again. Negative 2x plus 8y equals to 10. 2x minus 6y equals to 18. We have opposite coefficients here, negative 2x and 2x. So negative 2x minus 8y equals to 10. That's the first equation. In the second equation, we have 2x minus 6y equals to 18. So hence, we said the x's have opposite coefficients. So therefore, we will add to eliminate. We add this, and it eliminates 2x, negative 2x and 2x. So adding negative 2x and 2x will eliminate the x's. So we have negative 8y minus 6y is going to be negative 14y, which is equal to 10 plus 18 is 28. We want to variable y here by dividing both sides by negative 14. Negative 14 cancels negative 14. So we have y equals to 14 into 28 2 times. We have negative 2. The value of our y is negative 2. So we substitute the value of y in any of our equations that we have here. Let's say we take the first equation, which is negative 2. Let's consider first the two equations, which one is simpler. And we realize that negative equation 2 will be simpler to avoid the negative signs. Negative 2x minus 6y equals 18. So we substitute the values of y here. 2x equals to 2x minus 6 into negative 2 equals to 18. So we have 2x, negative 6 times negative 2. We'll have positive 12, which is equal to 18. Now we want to isolate our variable here. Let's undo the 12 by subtracting 12 from both sides. We have 2x, negative 2, 12 plus negative 12 will obviously eliminate. And then we have 18 minus 12 is 6. So we divide both sides by 2 to isolate our variable here. 2 cancels 2. 2 goes into 6 is 3 times. So x is 3. The values of y is, we have our equation as x is 3 and y is negative 2. We can further go on to proof. I'll leave you with that. You can substitute the values of x and y in the equations to check whether both sides of the equations will be the same. And if they are the same, you know that very well you've done a good job, your answer is right. If it is not the same, you still need to try again and then go over it. I thank you for your kind attention. Don't forget to be washing your hands and adhere to the. Thank you very much.